last but not least is 42, which is a hypothesis testing problem. And if you'll recall, to do hypothesis testing, those formulas I had on the previous screen, we're going to still need standard error, and we're going to need the z-star, a different z-score formula, which is the sample mean minus the population mean over standard error. In this case, the national mean on the ACT is 21 and standard deviation is 4.7. 40 NVHS students took the ACT and scored a 22.4 with the same standard deviation of 4.7. So the NVHS counselor believes that our students did indeed perform better. The question is, did they perform statistically significantly better? So we're going to complete a hypothesis test. However, on number 42, the alternative should be mu is greater than 21. That is a typo, and that is my fault. Okay, and we are supposed to do it at a 0.05 level of significance, which means in reverse we want to be 95% confident. They've set it up. The null hypothesis is that our students really are just similar to the same mean as the population. We believe that they are actually performing better. Okay, so our goal is to disprove the null hypothesis, if you recall, and by doing that, we have to find the p-value, or the probability of this, by finding z-star. But before I can do that, I need standard error. So in this problem, I have to notice that standard deviation was 4.7, and I sampled 40 people, so I would have to do square root of 40. This gives me a standard error of 0.743. We usually carry standard error to 3 decimals. Now I can calculate the z-star, so I can look up the probability in the table. It says take the sample mean, which would be the mean of the NVHS students, which is 22.4, minus the population mean, which is 21, over standard error, which we just calculated, of 0.743. This gives us a z-star score of 1.88. Okay. We believe our students scored better, so what we're out to find is the percentage chance, the probability that the null hypothesis could be out there on the edge. So you're going to go to your table. In the table, you're going to look up, that's a picture of column C, so you're going to go find a z-score of 1.88. Look up column C and discover it's 0.0301. So the p-value, or the probability of this, is 0.301. The chances that the null hypothesis is true, that our students were only the same as everybody else. So since that is less than the 0.05 significance that they were asking us up here, they wanted our probability to be less than 0.05. It is. That means we have disproved the null hypothesis, or, as you recall, we are rejecting the null hypothesis, which means we are accepting the alternative, and yes, it does look as though our students scored better.